Hello, my name is Jordan Gibbs here at the Career and Technical Ed at Gull Lake High School. I am currently taking independent certification and I am working towards getting my Comptia Network Plus certification. Um, this is my third ePortfolio update, and I just wanted to share with you what I've gotten through so far. So, as you might remember from last week, I got through uh, Unit 3, Section 3 of Unit 3. Now I've gone a little bit farther. I've gotten through Section 4, 5, and 6 and completed the exam, and I've also completed Section 1 of Unit 4. Um, as we remembered last time, um, from my last video, um, yeah, I was on Unit 3, and then I was talking about twisted pair cabling, fiber optic cabling, and all the connectors that go along with it, along with some wiring implementation that's right here. Um, well, not wiring implementation, wiring distribution, my bad. Um, yeah, now I've gone through quite a bit more of it. So let's start off with section 4 that I went through. I learned like some different ways to troubleshoot media or connective media. Um, like how you'll have trouble like EMI, electric magnetic interference, crosstalk, um, and things like attenuation, like where it's like signal loss over time, stuff like that. I went through network adapters, like transceiver modules, uh, media converters, and then networking devices, like when you think about like routers, switches, bridges, hubs, etc. And then section 1 of Unit 4, that kind of focused on IP addresses, subnetting, binary, learning binary, how to configure stuff. And I think, and last time I also did a presentation, so I'm going to try to go through a presentation again to show you what I've kind of been learning. So first off, here's my title. Yeah, troubleshooting. So one of the issues I learned about was crosstalk, where like you'll have this wire pair over here, like the electrical signal, messing with this wire over here, um, just interfering with it. It's basically when a wire in the same cable will pick up the same signal somehow, right? And you'll have different kinds like alien crosstalk. You'll have near end and far end crosstalk, which those are basically the same thing. It's just where they're picked up at, where the crosstalk is picked up at. So next, you'll have network adapters. Some things we went through with network adapters. We learned the different kinds of network adapters. Well, actually, hold on. Going back, I can't say I'm completely done with troubleshooting because there is electric magnetic interference, right, where like an electrical signal will interfere with the wires. Like for example, let's say like there was a generator nearby these wires and there was like some electric signals that got picked up from the generator to the wires, right? You'll see that's what electric magnetic interference is. It's when like electrical signals from a different outside source gets into the wires and kind of corrupts the data inside. Now there are some ways to fix this, like fiber optic cabling, like because that uses light instead of electrical, so they're not really affected by it. Um, you could also use shielded STP, shielded twisted pairing. It's when like there's some foil that goes around the cables in order to shield it from electric signals. Now, to reduce crosstalk, you'll probably want to twist these strands more, because the more you twist the strands, the less likely they are to interfere with each other. Um, that goes with what I said earlier with the crosstalk stuff. And like when you're putting in like the Ethernet ports, make sure it stays as twisted as possible, all the way up to the end of it where you're gonna have your port in, just so that like there's not a whole lot of twisted, so or just so there's not a whole lot of crosstalk. I mean, you could also have attenuation, and this will be like where a wire is like really really long, and there's just like no breaks in it, and this will cause like the electrical signal to like lo- be lost over time, like, or not lost over time, lost over distance. So let's say that this wire was like, I don't know, like a mile long, like, and it was trying to send something to another computer. There's gonna be an extreme amount of attenuation or extreme amount of signal loss because the cable is so long. And that was being pretty dramatic. You probably won't see a Ethernet cable that's that long, but still, this is and to fix this, you'll probably use something like a repeater, which I'm gonna get into the next slide. But it basically it strengthens a signal over time. Like, let's say like in between in between that mile long Ethernet cable, you'll have a few repeaters, which basically keeps the signal strong. It'll amplify the electrical signal, allowing it to get to the other end of the cable nice and securely. There's also things like open circuits, like where, let's say like there was a nail that somehow got penetrated through this cable right here. That's an open circuit. You're gonna have a lot of signal loss. The signal won't be able to reach because it gets like infused into the nail, or whatever's causing the open circuit. If you cut the wire, the signal's not going to be able to pass through, you know, the wire. You also see like human error, like like miswiring. You'll use crossover instead of straight through cables. So it's kind of up to the person, like, to keep their wires maintained in pristine condition. Pristine condition. Um, okay, now we're ready to move on to network adapters. So network adapters, you'll see this is a transceiver module, I believe. And this is like you'll plug this into a switch, and like let's say like a switch only had like Ethernet ports, right? Um, and let's say you had a fiber optic cable. So what you do is you'd plug a SFP transceiver into a switch, um, and that you'd also plug the fiber optic cable into the transceiver. And what this would basically do is it would allow the fiber optic cable to transceive its signals into electrical, or into the signals that could be picked up by the switch, basically. So in short, it allows uh, different signals to be transmitted into a switch or router, etc., depending on what it is. Now, this is a media converter right here. As we see here, we have two fiber optic cables. Well, not two, but this is one fiber optic cable, and with two different ends, and we have an Ethernet. So let's say like you wanted to convert media between a fiber optic and a Ethernet cable, right? So you would plug the fiber optic into the network adapter, and you'd also plug the Ethernet cable into the adapter. And what would happen is basically the light signals would be converted into electrical, Or if you wanted a network adapter that does the opposite, where it converts electrical into light signals, it could do that as well. So that's what a media converter does. It converts signals. Well, I should say it's like a translator. It translates signals between different cables. Network devices. We got switches. They remember MAC addresses based on it's. They remember MAC addresses based on the MAC or based on signal sent. So let's say you had two computers connected to here. A computer sends a packet or something to get sent to another computer, and it will attach a frame, and it'll have its MAC address, and the switch will remember its MAC address. And if it doesn't know its MAC address, it'll put its MAC address from the frame into a routing table, and this will allow the switch to, more fastly send signals from one computer to another, if it remembers that MAC address. Now a bridge, it's kind of like a watered down version of a switch. Uh, so basically, it remembers MAC addresses. Signal in it could send signals from one network to another, basically. And it does that via the MAC address. And so yeah, a bridge basically sends signals to other segmented networks via the MAC address. So that makes that a layer 2 device along with the switch. So what I like to think of, to make it easy to remember, I just think of a switch as a better bridge and a bridge as a downgraded version of a switch. The only difference is switches are more precise. They have more ports. They could send it directly to the device. Um, but a bridge, it might have to go through certain traffics in order to send a signal. Now a router. The only thing I'd really have to say about this device is it forwards packets of data, which operate on layer 3. Um, and it basically just routes different packets, routes data in order to get to a specific device on their network or on a different network. That's the best way I could explain it. Now a hub, it's kind of like a switch. Except it doesn't read the MAC addresses. So that's why this is a layer 1 device, because hubs basically, let's say a host on this network wants to send or let's say host A wants to send a signal to host B. Well, host A will send that to the hub, and the hub will send that signal everywhere. Um, it'll send the signal everywhere, and hopefully only the right device that needs it will send a signal back, and that signal will also be sent to everyone. So next we got repeaters. I talked about this a little bit on a few previous slides. It's a device that amplifies signals between devices. Let's say this is an Ethernet cord. It's really long, and it ends up having a weak signal for some reason. If it's plugged into the repeater, it's gonna amplify that signal and send it right back out with a stronger signal, so that there's not a lot of signal loss. That's the function of a repeater. And next we have numbering systems, IP addresses, and subnetting. We learned how to convert binary to decimal, hexadecimal, stuff like that. And we learned the different 8 bits. You'll see octets for IP addresses, right? So these dots, they're basically different octets. And they basically go from 0 to 255 in each octet, and each and there's it's 32 bits, and there's 8 bits in each byte. So that's kind of how we learned about that. Um, but I think a good way to show you guys like that I actually know like how to do IP addresses would be like to show you guys an example. So what I have here is an IP address and a /26 subnet mask in CIDR notation. So what this basically means is that the subnet is going to be 255.255.255. And then there's 28, so that's 128 plus 64. So I believe that's like 192. 192 it should be. Yep, it looks like I was right. So yeah, it's good to do this stuff with math. So for subnetting, basically, I'm gonna convert all this into binary. So I'll be back in a second. So what this subnet is basically saying is that we need to borrow 2 more bits from the host portion of the IP address. So for that, what I'm going to do is I'm going to find the number of hosts. And to do that, I'm going to do a calculation of... So what I like to do to find the number of hosts is we do 32, subtract the number of basically the number in front of the subnet, or the slash. So 2 subtract 28, that gives us 4. And to find the number of hosts available, what I do is I do 2 to the power of 4, which is the amount of hosts, or amount of bits in the host portion available. And I would do subtract 2, because you always subtract 2 because of the network and broadcast address. And that leaves you with a number of 14. So that's how many possible hosts you could have. So first off, we know the network address, net, is going to be 192.168.5.0. And we should know that the first usable IP address in this is going to be a 1 that's over there. So it's going to be copying this first usable IP. I'm going to first usable IP. Oh, geez. First usable IP. And that's going to be .1. And then to find the broadcast address, in this binary, it's basically just going to be like all 1s. So it's going to be... So I want to admit that I did make a mistake here with the last few digits here. So for the broadcast address, it's going to be this all set to 1s, broadcast. Ooh. So basically what this is going to do is going to be like 1, 2, and then 4, and then 8. So I believe that's 15. So it's going to be 192.168.5.15, because 8 plus 4 plus 3 is definitely that. And I think I messed up here. I accidentally did a typo. But that's going to be the broadcast address. So the first usable IP is that, and then the last usable IP is going to be, it's going to go from that, and then it's going to be, this is going to be 0, and this is going to be all 1s. So it's going to be 1 less than the broadcast address. So it's going to be 192.168.5.1, or 14, I mean. So now we have the network address, we have the usable IP address ranges, and now we have the broadcast address. Now, I know this video was a little scruffed because I am kind of new to learning this stuff. Um, but I just want to show off my knowledge and how I learned to understand these things. And just so you know that this is right, I did look it up in ChatGPT before. I didn't use this to cheat though, because as soon as I put it in, how do I find the IP address range? I opened this up. So I couldn't really see any answers, but I know how to do this at least. So just to show you, this is what I have for it. So yeah, that's what I did for that. And I figured, it might be good to, just show off some of the labs that I've worked on throughout this whole entire October month. So I think there's a few in here. So I've installed network adapters, converted media converters, for like fiber optic cables. I've done that. I've installed a hub, switches. I've done those labs. Configured a home router. That was pretty interesting. It wasn't that difficult. And then lastly, I think the last one I did was configure IP addresses. So what I did is I basically went into a computer that had network interface cards, and what I needed to do is I needed to configure those IP addresses to what they gave me. And that was really difficult at first, but then it was kind of easy to understand, like once I saw like how to do it. And the IP addresses for mobile devices, that was pretty easy. And concluding, I might as well show you off some notes that I've taken. So there was a lot of notes for Unit 3. But yeah, each little section I've taken notes on. Even the videos, I go through those and take notes on those using ChatGPT, of course. And for my Unit 4, as we see, I've gotten through the practice quiz just all throughout this section. So this is my progress and what I've been able to done, or what I've been able to do in the past October month. And I'm hopefully gonna keep on continuing on this pace and get through all this training and hopefully get my Comptia Network Plus certification. Sorry if I bored you a little bit, but thank you for listening to my yapping on what I've been trying to do. And I hope you guys have a good day.